Hi everybody, this is the lab 11 that we're going to be doing. We're going to be looking at another PCB design tool this week, and it's from a company called ExpressPCB, and there's another company called PCB Express, and they also offer a free design tool, but we're looking at ExpressPCB. It's the name of a company, and the advantage of using PCB Express is that you download their free design tool, you design your circuit, your PCB, and you send it to them, and they know exactly how to interpret the file that you sent them, and it's quite simple, so everything stays within one shot. So I wanted to say a few words about building a board, if you ever had it in your mission to build a board. So you would you would create your schematic and your layout as you did last week in Eagle, and then you would go hunting for a company, and I'll just look at two companies. One of them is ExpressPCB. This is the one that we're doing this week. So if you go to their website, ExpressPCB, they again, you can download this software, and you can if you want, design the board. And they have different kinds of boards, but what we'll do is compare the pricing for the standard board, which is their least expensive board. It would look something like this. It would be double-sided, so if you flipped it over, there'd be wire traces on the other side as well. And but there is no silk screen, so there's no image showing you what the component looks like. Anything that's imaged here is actually metal on the polymer board. Some of their other boards, would have a silk screen on them. Probably more familiar to what you're used to looking at. Okay, so we're doing the two-sided standard board. These other mini boards go up to they get more expensive. You can get more layers of metal, and so on. So we're looking at the standard board, and let's just say we wanted to look at a board that was 1.5 inches by 1.5 inches, and we wanted 50 of them. And when I calculated this to be, let me just go somewhere, I'll write it down. ExpressPCB 1.5 inches times 1.5 inches. According to their calculation here, they say it is $55 up front, 0.65, 65 cents, times the number of boards. So in our case that's 50, times the square inches of the board. That's why your incentive to keep it small. And if we're 1.5 by 1.5 inches, that's 2.5 inches, plus 1 times the number of boards. So that would be 55 plus 0.65 times number of boards times 2.25 square inches plus 1 times 50, and that comes out to $178 for 50 boards. So that is a roughly $2.46 per board incremental. So if we ordered another board, if we wanted 51, it'll cost us $2.56, and it's $3.56 per board, and that includes the upfront expense, the upfront $55. Okay, so you can get a feeling for how much that will cost and how much it costs when we buy them for you guys, because this is when we buy a bunch of boards, we will have them manufactured, and they cost roughly $3.50 a board. The alternative is to go to another company, and Sunstone Circuits, and we have bought boards from these guys. Again, similar features. It's a standard board, 2 layers. This one has an optional solder or a white silk screen on the top. I'm sorry, this is lead finish only. Okay, and then the size of the wires and such. So I put into their pricing tool 1.5 inches by 50, and it came out to $362. So let's see what happens. 362. If I make 51 here, so it's quite a bit more per board. So it's less upfront costs, but the incremental costs are higher. So I think if you were only buying 1 or 2 boards, this would be the cheaper way to go. But if you're buying a bunch of them, it gets more expensive. So if I put in 1 here, it's $31 compared with the other one, which is over 55. So this is the market that they're gearing towards. So that's just a little bit about where to buy your boards, and might be a good project to do sometime on your own if you ever had some wild idea of a circuit board you wanted to build and you didn't want to build them on a VTC single side board. You could go out and order one. Okay, so now we're going to kick around this tool, ExpressPCB. Go to your All Programs and open it up. So you're going to be using the schematic tool, ExpressSCH, and next week we'll be doing the PCB. So the one with the triangle on is the one you want. So there is a, this is geared towards people like ourselves who are, maybe not full-time circuit board layout people. And so there's a very good user's manual, and you could easily do this lab without listening to this lecture at all. So it's a quick start guide, and typically whatever question you would have is in this help guide. And this is more realistic to what you're going to have at a company. You're not going to have somebody giving you a tutorial every time you have a problem, but hopefully you can find what you need on the web, or you keep these videos and you can refer to them. Okay, so my goal in this lab is to create the flashlight circuit that we've been looking at. Actually, this is a slight modification, but it's a flashlight circuit. So you're going to create figure 1, that schematic, and you're going to learn how to create new parts and give them names and values, and then modify one part and save it as a custom component. So you're going to find that this might be a little bit easier than Eagle in that regard. So that's going to be something like my custom component. It's just a schematic, doesn't matter what it looks like. Okay, so I'm in my ExpressPCB. All the components that you'll need for figure 1 are in the library. So you should be able to find all these parts in the library. How do you find a part? So you go to Component Manager, and they actually have a pretty good search tool, resistor. Okay, so insert into schematic. If I need 2 resistors, I can click click on this one, it turns blue. And I can copy it. Control V, Control. It's a lot easier than Eagle that way. So I can do copy paste. But note that both of them have the same name. When I did this in Eagle, it automatically updated the name of this to be R1. Not in this tool. So I need to assign it a name. So this is R1. And let's say that's 1,000 ohms. Now it doesn't really matter what I put here because I'm not simulating it. But I do need a unique name. Otherwise, the tool won't know which one is which. It's like they're identical twins. This one would be R2. So every component that you create, you need to have a unique name for. So all these components have unique names. This R2, R3, C, C1, C2. If I don't, I'm going to get an error when I netlist. So go ahead and find all these components. This is an LM556, and again, that should be in the library. Component Manager, find 556. Okay. Okay, this is actually one chip with 14 pins. So that's why when I dropped it in there, I got both of them. But it's one chip, 14 pins, but there's two identical circuits in each one. That's why this one is the only one with power and ground. When I go to wire them together, I'm going to use the Place a Wire tool. And as soon as I get it there, I enter, and they're wired together. And I believe it should stick. If I try to move this one, it follows it. So that's a good way to check to make sure you got connected. So why don't you go ahead and wire that circuit, and then I'm going to do that as well. Okay, so I wired mine up. Something like you guys should have. Just a couple points here. I found the ground symbol under Component, Symbol Manager, Library Symbols. And for the NPN, I simply used an NPN, as it said in the write-up. So I searched on an NPN, and I dragged that into my schematic. And now what I want to do before I declare victory on this, note also that I changed all the names. So I changed C1, C2, C3, C4, and so on. So these all have to have unique names. What will happen if I make this the same as C3? Let's see what happens. Check for netlist errors. It doesn't give me an error on this, but I'm going to need that to be C4. Otherwise, it won't be unique. It'll actually wire them together. The other thing to note here before I redo that check that I'm going to do is note that it is not easy to draw this thing into modular components the way I could in Eagle. So I couldn't like draw part of the circuit and have it virtually connected to another component because I can't name these nets. They are what they are. Okay, so now what I'm going to do is do a check on it. So under File, check for netlist errors, and I get an error at the NPN. And the reason is because this part wasn't completed. So what I'm going to do, note how this part has pin numbers and names. Each pin has a name. So I'm going to name, I have to go in and name these pins. So in order to modify that, I'm going to drag it out of my schematic. I'm going to work down here with it. So just delete these guys. I'll drag it down here. And I have to modify this component now. So what I'm going to do is select the whole thing. Component, and ungroup it. So now it is no longer a component. Now it's a bunch of independent things. So I could, move this away and so on. So a component is made up of a bunch of sort of just lines, and these ball things are pins. Okay, they denote that you have to connect to them. And right now these pins are not named. So what I'm going to do is name this pin. I'll name it 1, and I'll give it a name of C for collector. I'll get it out here so it's not in the way. This will be 2. And I'll give it a name of B for base. Okay. Now I'm going to save it. I have to save this part now. So I'm going to select it all again. Component, group to make component. I'll give it a name of U1. Actually, no, I'll just call it U, because I think one of the chips is named U. 1. Nope, it's the same name as this one. Gotta give it another name. U3. And now I can save this component. I'm going to move this back into my schematic. Now if I check it, there were no errors found. And I think I shall save it in my folder for my flashlight. Okay. And that should do it. Okay, before I completely close down, I want to just do one more thing. I just created this new component. If I ever want to use it again, so I'm going to click on it, it all turns blue. Component, save as custom component, and I'll call it npn_3904 as a transistor. Okay, now when I go to my component manager and I look under custom components, I have the one I just saved. So in effect, this becomes sort of my library that may or may not grow as I continue to use this this tool. Okay, so you just created a custom component in the NPN. Now we're going to create a custom component that has 4 inputs and outputs. It's called the two-legged creature, but it's got the critical thing is it's got 4 pins, and all the rest in between here is just design work. So what we need to do is go back into our workspace. You can work in the same workspace as this one, or you can save a new file called two-legged creature. But I'm just going to work in here. Just make sure you copy and paste this into your Word document. And I'm going to create a new component. And I don't even need to declare myself. I just start working. I need 4 pins. So the pin tool is here. 1, 2, 3, 4. And then some design work. And I'm sure you guys will be far more creative than I'm being. Now, don't use the wire tool for this one. Oops. As it is, the stuff I'm doing now is just features that are in the component. They're not actually wires. So, place a wire. Or, sorry, I don't want to place a wire. I want to place a line. And you guys can fill it out. So I've got my pins and my design. Now what I want to do is I want to make sure that these pins have names. So this will be my, say, VCC, and I'll call that 1. Oops, wrong way around. 1 VCC. And you can move these to be more conveniently placed. This will be his right leg. Left leg, pin 4. Okay. Now when I'm all done with that, and I want it to be a custom component, what I'll do is select the whole thing, group to make component. I don't have to give it a name, I just group it. Now when I select on it, it gets the whole thing because it's a group. And I'll click on it again, and I'm going to save it as a custom component, and I'll call it the two-legged creature. And that's it. So now, if I ever wanted to use it again, it's in my, I made 2 of them here. It's in my library of selected components, and I can use it anytime I want. So that's all there is to this lab. So copy those into a Word document and submit it through Blackboard, and we'll do this again next week for the layout piece of this software tool.